Hi, I'm Scott McBrien, a technical contributor to the Red Hat Enterprise Linux team. Today we're going to be talking about optimizing performance and uptime of Red Hat Enterprise Linux. Alright, so what we're looking at here is the terminal of a system that has Microsoft SQL Server installed on it. And to verify that everything is operating correctly, I'm just going to run an SQL command to query the version of Microsoft SQL that's running there. And that was able to successfully resolve. So we're running Microsoft SQL Server 2019 on this box. Now we haven't really done a whole lot to this system. In fact, if we take a look at the active TuneD profile running on the system, its current profile is virtual guest because it was auto-selected based off of this system being a virtual machine. Virtual guest is not highly optimized for running mission-critical workloads like Microsoft SQL Server. So this is something that we may want to change. So taking a look at the available profiles on the machine, we can see that most of them are workload-based, things like balanced or HPC compute, or one that's pretty common is throughput performance because it broadly tunes the machine to run a bunch of different server workloads. But one that I see that is missing from this list is the Microsoft SQL Server one that Red Hat distributes. So I'm going to go ahead and install that using yum. And then once it's finished being installed, I'm just going to take a look at the list again. Sure enough, it is now available as an option for us. And we're going to take a look at the configuration of what it's going to do if we switch to this profile. So first off, I noticed that it's based off of the throughput performance, which is a profile that sets up kernel settings and system settings to do well for a variety of common server workloads. But then in addition to that setting, I can see that the sysctl section, it's making some changes to how the kernel handles virtual memory mapping, the NUMA balancing on NUMA CPUs, and then the thing that's going to be the most interesting to us is that series of kernel sched adjustments. So this is controlling how the kernel works with the CPU scheduler, and what we're doing in this Microsoft SQL profile is making that scheduling much more granular, meaning that the system can be checked more frequently to see if it's time to change a process running on the CPU. All right, the next thing I'm going to do is install our performance observability tools. And to do that, I'm going to install two RPMs. I'm going to install the kernel devel RPM for our currently running kernel, and I'm going to install an RPM called BCC tools. All right, so kernel devel provides libraries and some other things for compiling software against our currently running kernel. The BCC tools package provides a whole bunch of applications that Red Hat has written and provided for hooking into the extended Berkeley packet filter, or eBPF, virtual machine that's running within our kernel. And what it allows us to do is check on different stats and system calls and a whole bunch of things associated with a process or with different modules running on the system. So again, the RPMs I installed were kernel devel for our currently running kernel and BCC tools to get that selection of tools. And then it pulled in some dependencies as well. All right, so we're still taking a look at what we can do to optimize this system for Microsoft SQL Server. But one of the things you can do on SQL Server itself is use column store indexes to make your queries faster. So our performance observability tool is going to take a look at column store index operations, but I just wanted to show you the difference between using column store and not using column store. So if we don't use column store, here the script is just doing a variety of SQL queries without using a column store index. And we'll see that it takes several hundred milliseconds per query. And then we're going to do the same list of queries, this time using a column store index. And we'll see that it takes much less time. So one of the things that you can do to just on the database side of things to make things more efficient is by utilizing column stores if you're not doing so already on Microsoft SQL Server. All right, but we're talking about Red Hat Enterprise Linux and changes that we can do to Red Hat Enterprise Linux. So what we're going to do is take a look at a command called CPU dist. And CPU dist is going to take the process ID of our column store query that's running, and it's going to show us the distribution of time that different processes are taking to complete. So this is a really gnarly command to basically run that column store index script and then take that column store index script and pass its process ID to our CPU dist command. And let me run it one more time. All right, you can see that there's some variation based off the runnings because each one is a little bit different based off of the processes running on the system. Let me run it one more time to see if we can get a consistent output here of our histogram. Because in the performance world, you're never to do something once to verify. You need to do it several times to make sure that it's consistent, right? And these two histograms look pretty consistent with each other, all right? So what we're looking at is this column is a range of milliseconds, right? Which the unit of measurement that we're using is called USECs, which is an abbreviation for milliseconds. Microseconds, not milliseconds. Microseconds are USECs. And what we see is that the distribution of processes running on the system, that a lot of them are running up here in this 4,000 microsecond to 8,000 microsecond area, and then some more are down here in the 64 to 127 and 128 to 255. And it would be really cool if we could break up this block of longer running processes potentially and have them slot down here in the smaller amount of microseconds per process. So remember when we were looking at the TuneD profile, and in fact let me show you the contents of it again. So what this TuneD profile will do when it's applied is make the scheduling granularity more frequent. So the kernel will more frequently take a look at what's running on the CPU and potentially switch the process that's running there. All right, so let me go ahead and change to this TuneD profile. And now those customizations of the scheduling granularity have been applied. And we're going to take another look at this CPU dist performance observability tool. So remember, we want to take these longer running processes if we can, and maybe make them shorter running processes. All right, so let me run it one more time so we make sure that our output is consistent. All right, and that looks pretty consistent. So what we're looking at here, remember last time when we ran this column store index using the default tune settings for CPU granularity, a lot of our jobs were falling in this 2048 to 4K microsecond range. But now almost none of them are falling in there. And instead, they're being concentrated more up here in a smaller amount of microseconds. And what that tells me is that because of the CPU granularity we were using before, where the kernel was checking less frequently to see if a job was finished and change what was running on the CPU, it's now checking more frequently and finding that our processes associated with our SQL queries are finished and can therefore be swapped off the CPU for something else. And what that means is that if a query is taking a long time, it can stay there and complete, and that's what we're seeing up here where it's taking longer periods of time for a process to complete. But if it's done, we can go ahead and remove that process off the CPU and slot another query process on the CPU to get it going, thereby getting more consistent scheduling on the CPU for all of our running queries. All right, so that is doing some tuned changes to the system to optimize our system for a specific workload. And here we did that with Microsoft SQL Server.